This is a continuation of 13.3, looking at Surds. There are no new ideas in here, it's just me going through the questions that didn't fit into the previous video, because the videos do need to be less than 15 minutes. So here I'm doing the harder questions where we're doing some rationalisation and simplifying some more difficult expressions with roots in, which we call surds. So this will be all me sort of handwriting again. Hopefully you can make it out and it will help you to work through 13.3. Okay, good luck.
This one's got a lot of steps in it, but if you take your time and think about all the things we know about negative numbers, multiplying by negative numbers, and expanded double bracket, don't rush, this will be fine. We'll just work our way through one step at a time. So first thing is to multiply out the double bracket. So I've got 4 times 6, which will give me 24, and then 4 times minus 2 root 7. 4 times minus 2 is minus 8, and I've got that root 7 on the end. Now I'm going to do 7, in fact it's minus root 7 times 6, so it is minus 6 root 7. Then I've got minus root 7 times minus 2 root 7. I've got minus times a minus, so it's a plus. I've got that 2 there. I've also got root 7 times root 7. Root 7 from there and root 7 from there. Root 7 times root 7 is actually 7. So this whole thing at the end comes out to be 2 times 7, which is 14. So let's simplify that all together. If you look at the numbers, I've got a 24 at the front and a plus 14 at the end. So that gives me 38. If I look at these terms with a root 7 in them, I've got minus 8 there, because it came from 4 times a minus there. So that gave me the minus 8 root 7. And I've also got a minus 6 root 7, which came from that minus root 7 times by the 6. So in total, minus 8, take away another 6, it's going to be minus 14 root 7. Okay, one step at a time and you'll be fine with that. Good luck. Last question, question 9. This is where we're going to be doing that rationalising. So I'll do 2 of these, and that'll be us done, and then you can start working through the exercise. I think a common mistake here would be people would think, oh, just multiply top and bottom by root 54. But you've got some really big numbers there, so the first thing I would do is to try and simplify those. And some of you might notice that 18, 27 and 54, 9 goes into all of those, and 9 is a square number. So this, if I take 9 out of that, would become 3 root 2, because 2 times 9 is 18. If I take 9 outside the inside of here, 9 is going to come outside and become 3. I'm going to have root 3, because 3 times 9 is 27. And on the bottom, 6 9s are 54, so the 9 comes outside to be 3, and what I've got left inside is a 6, because 6 times 9 is 54, but I've taken the 9 out to be a 3 here. Old-fashioned bit of maths here, we can do something called cancelling out. I've got a 3 on the top and a 3 on the bottom, so they cancel out with each other. I'm doing 3 divided by 3, which is 1. So in fact I can take this out just to be 3 root 2 times by root 3 all over root 6. In total, what I've got now is 3 root 2 times root 3. That will actually become 3 root 6 divided by root 6. Now again, cancelling out, root 6 cancels out with root 6, so the full answer is just simply 3. That was a beautiful bit of maths. I'm sure you all enjoyed that. Okay, lots of steps in here. When you divide by a fraction, you might remember from Maths, If you look on the right side, flip that number over, then you can multiply. I'd say that'd be an easy way to tackle this. So that's what I can swap it around to. I looked on the right side, I flipped that fraction over, then I multiplied. Again, 9 goes into both of these, so I can rewrite that as 3 root 2. 9 into 45 is 5, so 3 comes outside, I end up with 6 because 3 is multiplied by 2. 6 root 5, because 5 9s are 45. Root 8, root 10, there isn't a common square number in those, so I'll just leave them as they are. And then if I multiply through, I'm going to end up with 3 square root of 2 eighths is 16. That's quite nice because that will square root. And on the bottom I've got 6 square root of 30. Sorry, 50. This made my writing. 5 times 10 is 50. So on the top, we write it down here, square root of 16 is 4. So on the top I've got 3 times 4. On the bottom I've got 6 root 50. You saw from my one of the early examples I did on the PowerPoint, 25 goes into that. So 25 can come out. 5 times 6 is 30. And we've got left in there is root 2. Now I've actually got onto this, I'm actually rationalising. So I've got times the top and bottom by root 2. Root 2 times root 2 is 2. I've already got a 30 there on the bottom. And 12 times root 2 can just be written as 12 root 2. So total, I've got 12 root 2 divided by 60. 12 goes into that and into that, so I would simplify that down to be root 2 over 5. Again, another beautiful bit of maths that got down to a much simpler answer. Now I'm going to do one extra question because we haven't seen a lot of that rationalisation and it is quite a key skill. So for this I've got question 11 and 12. 11 says rationalise, which means getting rid of that denominator having the square root, and in 12 it says rewrite each of these fractions without roots in the denominator, which is rationalising. Starting with C, we've got 3 over root 7. To rationalise that, I don't want a square root on the bottom, so I times the top and bottom by root 7, because root 7 times root 7 is 7. 3 times root 7, we just write 3 root 7. Simple as that, it's just that we don't want a square root on the bottom. Moving on to E, very similar. At the moment I've got root 10 on the bottom, so I'm just going to times the top and bottom by root 10. Because root 10 times root 10 equals 10. And on the top, 5 lots of root 10 is just 5 root 10. They are now both rationalised because neither of them have a square root on the bottom in the denominator. So for question 12, where we start off with 2 over root 8, there are lots of alternatives on how to do these. You could just times the top and bottom by root 8, but you get something quite complicated. I think you're always better off if you can see a way to simplify this square root, to do that first of all. So we can rewrite that as 2 over the square root of 2 times 4. 4 is a square number, so 4 can come outside and just become 2. So we end up with 2 root 2 on the bottom and 2 on the top. Could cancel these out, just so I've got 1 over root 2, and then multiply the top and bottom by root 2. Root 2 times by root 2 is 2, and 1 times root 2 is root 2. And that would be considered quite mathematically beautiful.
There's a lot of content in there, so you might want to watch this video a few times, or you might want to watch it in parts and go through the questions. You would have worked out by now that you need to be good at your multiplication tables and to know those factor pairs to help you on all the questions in section 1 and 2. And then when you get onto the surds, you need to be good at recognising square numbers. So you can take a square number out of a surd, get it out of that square root, put it outside and simplify it. Okay, good luck. And if you've got problems, email your maths teacher. Hope it all goes well. I'll be moving on to chapter 14 in the later part of this week. Good luck, take care, and hopefully I'll see you soon. Bye bye.